All right, I think it's time for us to get started. Okay. So we have passed the midterm point of this CSE 8A in summer one. Okay, so what we'll be doing today is we'll kind of look on pictures transformations. Okay. In other words, we'll be looking at a little bit of filters and then like mirroring and flipping. This part can be a bit confusing. Okay. So especially when it comes to geometry. So we'll see how far we can go. And then after this one, next week, we will get started a little bit more about, we probably won't be able to finish everything in here. So next week, we'll continue to do this. If you look at our schedule, okay, so our syllabus in here, for week 4, we'll first on Tuesday, we'll finish the image processing, like whatever we couldn't finish today. And then we'll be looking at bitwise operation, which is another application of image processing. Okay. For this week, we already have the midterm. PA3 is due this Sunday. Make sure you finish it up. One last thing for this week, unfortunately, just summer is tight. We have another quiz. We have another quiz in here. Quiz 3. Okay. So make sure you work on the quiz tomorrow. It's going to be a similar format as our quiz 1, quiz 2. The midterm, I look at nearly every one of us did the midterm. I need to go through the midterm before I release it. So expect the midterm grades to be released sometime today, later today. Okay. The average of the midterm is around 80% from what I can see so far. 82%, I think. So it's a decent midterm. Okay. In fact, sorry, it's not 82%, it's 81%. Okay. When can we expect PA2 grades to be released? I think PA2 grades. Let me check. It should be released because everything is auto-graded. I'm not sure what do you mean PA2 grades? Couldn't you see what you got when you submit? That's the grades you got, and then you can see the concept questions.
I can't see the score that I got on the concept questions, but I can see the checkpoints that I got based on the PA. So I was just wondering because I'm not exactly sure what I got right and what I got wrong from the concept questions, and it shows me the total score once it's put into Canvas.
Okay. Yeah, I think we part the grades once a week. I think for this week, we'll part it to Canvas, then you will see the grade. So sometime this week. Yeah, the grade isn't on Canvas yet. We'll be there this week. We'll port it every week. Okay. Let me also remind my staff about that. Okay, so one of our tutors helps with that. I ported last week. Port EA2 and Canvas by the end of this week. All right. So later this week, you should be able to see it. Any other questions? I think on Canvas, you should see PA1, Quiz 1. Quiz 2 may also be there. I need to check. Okay. Now, let's come back to picture transformation. Last time we talked about the image processing, right? We introduced the idea. Today, we're gonna actually do it. So we'll look at the 2D list of tuples in more detail and look at some of the ways we can transform pictures. Okay. So first, if you look at the image, our images are stored in our program as a 2D list of tuples. So if you look at IMG, this one is a list, right? Because the highest level is a list. There are 4 elements in this list. Each element is a list by itself. And inside each of the element, you have 2 tuples. So you can visualize this being a 4 by 2 picture. 4 rows, 2 columns. Each of the tuple represent a pixel in the picture. Okay. If you draw out this in Python tutor, what you'll see is if you look at image by itself is a list. So image is pointing to this list. So there are 4 things in this list, and each of the elements in this list is a reference to a list. If you look at it. So these lists have 2 things, and each of the element in the list is a reference to a tuple object. That's how everything is stored in here. So if you count how many objects I have 8 tuples. Tuples are objects. I have these 4 smaller lists, and these are objects. And I have this one, that's another object. So it's 8 plus 4 plus 1, that's 13 objects. Okay. Any questions? Okay. So one way you can think about it is, in other words, the pictures, they're organized row by row. So the first row, this is the first row, second row, third row, fourth row. Okay. Normally, when we try to process the picture, we go through every pixel in a certain region. Okay, we load the image or we create the image. We get the dimensions, and then you use a nested for loop on the correct range because if you think about nested for loop, right, outer loop, inner loop, they would specify the a rectangular shape in the original picture, and then you grab the RGB value from the pixel, image ij. Image is a 2D list with tuple. The first index would give you the row number. Second index would give you the column number. This whole thing, in fact, is a reference to a tuple. So we will unpack that tuple into RGB, and then we manipulate RGB because you cannot directly change the tuple. You extract information from it, manipulate it, and then you use the new RGB values to create a new tuple and let this reference point to it. That's most of the time what we do. Any questions about this? So in the library that we have, we talk about load, save, right? They will allow us to interact with image files. And then we have create image. This part, in general, we use it to create a small image for testing purposes. And then we have the height, we have the width. Those are for dimensions. Summarize is not widely used. Summarize just print out the width and height. We can figure that out very easily using the height and width function. And then image string to file, this is useful for testing. Like for us to say, okay, are the RGB values of the pixels in my picture good or bad? Last time we did a demo on these functions. Are there any questions about this? All right. So let's look at this exercise. Okay. So I want to write a function that takes an image. This is a 2D list of tuples. I want to remove all the red from it. In other words, I remove all the red. How do I do this? Okay. I think we have a coding challenge in here. Okay. So red filter, I'll give you the link to the coding challenge on add stem. Can you do this yourself? Create this red filter function and filter out everything here, and then you write a tester to test it. You can see bear, you can see swan, so you can try to do that. Okay. Give me a vote once you are done. I'll give you 4 minutes at most. Okay. Should write this function. Okay. See if I have other coding challenges. Good. 1 minute. I create this red filter. If you're done, give me a vote. Okay. 2 minutes. Now this one is trickier, huh? You do have access to the CSE 8 image.py, right? So you're mostly using functions in there. Last minute. All right, so it looks like one of us is done. Let's check, right? So in order for me to use this function, I need to import. Just add it to the solution. It's easier. Add the solution. Let's say filter.py. Okay. So the first thing you want to do is what? I, let's just use this one. It's easier. I have everything in there ready. So we'll say import Java, no, not Java, import CSE 8A image, or I should say from, let's import asterisk, right? Now I'm ready to process this picture, and I don't have to load anymore because I already assuming that I have access to the list of tuples. I need to get the dimensions though of the picture. So it's h equals to image height of the image, and then width equals to the w equals to the width of the image. Now I'm ready to write my nested for loop to take care of that, right? For I in range of h means for each row, h has something to do with the rows, right? For j in range of the width, I need to look at each of the pixels. I would extract the RGB value from the pixel. Ijth, in other words, any pixel in the region, right? The region is basically the entire picture in here. I want to get rid of the red. The way you take care of it is you can say, okay, now I want everything else to be the same, right? If, for example, the RGB value used to be 220 and 30, the new RGB value should be 0, 20, and 30, right? That should be the new pixels RGB. And the way I can take care of this is I'll just use 0 for the red, but I keep the same G, the same B. Whatever the G and B used to be in that pixel, I will maintain them, but I just get rid of the red. So G0, G, B. And then I'm done. So this function doesn't have to return anything because this 2D list of tuples, when you pass that 2D list of tuple to me, I would have the same reference to that 2D list of tuples if you create it outside the function. So there's no need for you to return this image. Okay. So let's load it up. I'll say pic equals to load image. I'll use the bear. Okay. And then I'll say red filter. I'll give you this image. Pic. Okay. And then I'll save it. I'll save it, save image. Save this picture as no red bear.jpg. Right? If I run this code, I'm going to pass in this 2D list of tuples to this function, and you will see the result showing that the bear would have no red after that. Right, so Python filter.py, I'm done. So you see there is a bear, there is a no red bear.jpg. If you remove the redness from the bear, this is what it looks like. Right? It's not very intuitive. Oh, this is the no red bear, right? But it kind of give you a good visual to say, okay, the picture looks different. But is it? Is this right? Although the picture looks different, you are not 100% sure a lot of times. For example, what if I say make the picture brighter by 30%. You say, oh, the picture looks brighter, but is it exactly by 30%? How do you know? Right? A lot of times we have to examine the RGB values of these pixels. So the way we're gonna take care of that is a lot of times we'll say save, not save. So image, string to file. I say, okay, pick. I said, this is the original.txt. So originally, what is the RGB values of the top left 20 by 20 region? So you just print out that region and we'll show you, okay, what it looks like. And in here, once I finish processing it, I will save it to another txt file. I say after.txt. And I can observe the differences between the content of these two files and know 100% sure if things have gone in the way that I was trying to do. Okay. So if I run the code in here, no red bear is exactly the same like before, right? There's no difference. But as you can see, there are two files created. There is the original, there is the after. Original is like this. These are the RGB values of the top left 20 by 20 region in the original bear. You can see 68, 72, 47. How about after? If you look at after, the only thing that is changed is the red. All the redness is gone. That's how you can be 100% sure, okay, filter out, all the red is gone. Because what if I ask you to say, okay, don't completely remove red, just make red half of what it used to be. You can do R double divided by 2, right? So red is half of what it used to be. If you simply look at the pictures, this is no red bear. It looks almost identical to before, right? Um, so either I set red to be 0 or half of it looks identical. But if you look at before and after in the text, this is before, this is after. You can see it's half of what it used to be. Before, this region used to be 68. Now it is 34. Okay, so this is the application of using this image string to file to help you debug or to help you confirm if your code is doing what it is supposed to do. Are there any questions? Okay, so this is the first exercise that we have about image processing. Okay. Any questions before we move on? All right. Second thing here. What do we usually do when we try to say manipulate the picture? So just some suggestions, okay? Number one, you want to start with something small. Like the bear is a pretty big picture. I remember it's like a 370 by 370 picture. So it's not huge, but I mean, it's hard for you to look at each of the pixels. So maybe it's better you create some image by yourself, right? And try not to create square images unless you say, I only test on square images. Try to create something strange like a 7 by 5 or 2 by 1, something like that, a small picture. And make sure that your code works on these small images. Once you make sure that your code works on these small images, basically you can print it out in like string image to file, print out the RGB values, then test your code on real ones. Okay. Make sure that your code works on different situations. Like what if the width is even? What if the width is odd? Would that impact my program, right? And if they do, how do I handle them? So that's in general the procedure. Okay. So in the context of this problem that we just did in here, we're using bear.jpg, but we can also create our own picture in here. Let me show you how you can create your own picture, right? So what I will do is this. Let me create a picture, image, say picture equals to, there's a create image, right? And so how tall is the picture? I say 7 by 1. 7 rows, 1 column. So it's like a vertical bar. You can also say height is 1, width is 7. That's a horizontal bar. The reason is just it's a little bit easier for me to manipulate. I'll say everything start with black. If you save this picture, say tester1.jpg. If you do that and you run the code, you're gonna see a tester1.jpg. It's just so tiny. I don't even know if you can see it, but I can't even click on it. Let me see. I can try to download it. Download it and then open it up. Uh, so this is what it looks like. Oh my God, it's the background is black and this thing is also black. Not good. Can I change the background? This one? I have no idea. Let me open it up in here. Okay. Sometimes these pictures are really hard to visualize. Let me use Paint to open it up. Okay. So you can see the picture is over there. I can try to zoom in. That's as far as I can go. So it's basically just a vertical bar. Okay. Is there a way I can visualize it a little bit in here? Open image in the new tab. Why is the background black? I have no idea. Whatever. Okay, so you can see it's a vertical bar in here. And you can change its color a little bit to give you a better idea. Okay, so I'll say, okay, 7 by 1. I'll say maybe pick 0, 0. I want it to be pure red. Pick 1, 0. I would say you should be pure green. And then pick 2, 0 will equals to pure blue. And then the rest are black. I'm just having just some changes in here, right? So now if you run the code and you look at this tester1.jpg, it doesn't refresh. It doesn't. Let me see if I can click on this picture. Yeah, okay, there it is. You can see, I don't know if you can see it. Maybe my picture is too small. But you'll see that up on the top, there is a red dot. There's a red dot. Sorry, just it's too tiny. What was the color that I could use in here? For some reason, I was able to display something much smaller than this one before. It's just the background. I think the background is bothering us. Settings. Let's see. Customize theme. Make it light. I think this probably will visualize the picture slightly better. Right. So now if I open up this one, I download this one. Save image as, save on the desktop. Now I open it up. You probably can see it better. I think probably you can see it slightly better now. You have the red, green, and the blue, and the rest kind just black, right? And this is in general the picture you say, let me test it. If it works, if it does, then I will use bear.jpg, or I will use like other pictures to test. Okay, so you create something small. Don't make it square, right? Make it like a strange shape and see if it works. Okay. Any questions? All right. Um, let's look at this example. Okay. Um, what I want to do is the following. Okay. This is what I have. Sorry, it's not all red. It's all blue. That's a typo. Okay. So I want the right corner, this right half, to be all blue in here. Okay. So what should I pick on 1, on 2, and on 3? I want this region. The entire width and the height of the picture is W and H. So I want to color this region to be all blue. What should I fill in 1? What should I fill in 2 and 3? Let's vote on 1 in here. What is the right choice for this blank? Right? So we'll stop the voting here. We disagree with each other quite a bit. It looks like C and D being the most popular. Now, I, if you look at I is in the first index, right? The first index is row. The first index is row. So we need to, our nested for loop would need to specify this region so we can process everything in this region. If you look at the row range for this region, it goes from 0 all the way to height -1. In fact, A is the right answer. For I in the range of the row numbers. So it's not C, it's not D. We're looking at the entire height of the picture, the entire height of the picture. That's H. Okay. Any questions? All right, so it should be the entire height, right? The reason why I is the row number is because I appears in the first square bracket. Now, how about J? J obviously is dealing with the columns. So can we vote on the range for J, please? Basically, this answer for blank 2. Think about it. All right, we'll stop the vote in here. We have a tie between B and D, right? So is it the entire width or is it this part? So if you give a range with two numbers, it means you start at half, you finish at W. Now, am I going through the entire width? No, I'm not. So it's not the entire width, it's not B. I'm looking at this region. This is the width region. This is the height region. So the width region, in fact, is half of the width, W over 2 to W. But unfortunately, this is also wrong. Why is this wrong? Because range would require integers. W divided by 2, if W is like 20, 20 divided by 2 will give you a 10. That looks okay. But if W is 21, W divided by 2 would give you 10.5, and that is problematic. You cannot have decimals. So the correct answer, D, is very close to be half of the width to the entire width. That is the right syntax for the range. Okay. Any questions? All right. Now I want to color everything pure blue in here. How about blank 3? What should I do in there? All right, we'll stop the vote. I think we have a strong consensus. Everyone of us voted for B. That's correct. Right? If you voted for A, you just keep the original blueness. Right? So it's not going to be a solid block of blue. It'll be just some variations of blue. Okay. So let's write this code in our coding challenge and we'll see how that goes. Okay. We'll just use the bear in this example. Okay. So let's create pic equals to load image bear.jpg. And then we'll say filtered, red, filter. Probably want to rename this. I call this just filter. Right. So I say filter this one and then save it. New bear.jpg. I'll try to color the right side of the bear to be pure blue, right? So I don't even need to extract the RGB now. I say 0, 0 to 55. And remember, we're going from half of the width to the entire width. Range going from A to B, right? Not including B, which is exactly what we are looking for because the last width column is at the index W minus 1. So if I do this, you'll see new bear. No, that's no red bear. This is the new bear. The entire right side of the bear is now pure blue. If you say I'm gonna keep the original B, I don't even have an original B, you can extract it. We can 0 a RGB equals to image IJ. And then you say I'll just keep the blue. Then what's gonna happen is you're gonna see some variations of blue, not pure blue. In other words, you can't remove the red and green. If you run it, you are not gonna see the blue block on the right side. You'll see the right side, in fact, looks pretty interesting here, where it just filter out all the other two channels. Is blue. It's not a block of blues. Okay, hopefully this makes sense. Are there any questions about this part? All right, then another coding challenge. What I want to do is the following. I want to write a nested for loop to make the top half darker by a threshold. So what is threshold? Threshold is like a dot 3 or dot 5. If threshold is dot 3, it means make the top half of the picture 30% as bright as before. If you say threshold is 70, is 0.7, it means make the picture 70% as bright as before. So can you write this code in here? The challenge is here. Let me where's the challenge? It's this one. Darken the top half. Here's the link. Okay. I'll give you a few minutes. This one is trickier. I'll give you 6 minutes. Okay. Can you do this? If you are done, give me a vote. Okay. Darken the top half. And the way you darken a picture is you make each pixel smaller. You can just multiply the RGB by the threshold. That'll be the new RGB value. Okay. 2 minutes. Okay. We have 4 minutes to go. You're already given the 2D list of tuples. You may want to first get to the dimensions, right? And the nested for loop to go through it. But the nested for loop should only focus on the top half. Oh, one of us is done. Okay. That's very quick. Try to solve this problem. Um, Top half darker. 3 minutes and 30 seconds. We have 2 minutes to go. Okay. So it's almost break time too. So maybe we should just, once we finish this one, we'll take a break, we'll come back and do it. Okay. But it's not break yet. Okay. Last minute. Only one of us has voted in. Only one of us is done. If you're done, vote in. Two of us are done. All right. I think due to time, let's take a pause in here. Okay. Um, it's almost break time, but let's just get started on this really quick. So normally the first thing you do is always get the height and the width of the image, right? That's what you want to do. And then we need to do the other stuff, the nested for loop. So from CSE 8A image import asterisk. Right, we have to take care of that. Now we need to have the nested for loop. What we have is we can say for you have to visualize this in here. Right? I'm looking at the top half. So if you look at the range for the height, in fact, it's half of the height. So the trick in here is I in range of half of the height. And the entire width, that is the trick. Okay. And then let's take a pause right now. Okay, let's take a break. We'll come back and we'll finish this one. Okay. But the most important thing, this part is the tricky part. Right. So you only take care of half of the height. All right, let's take a break, come back 12 noon, and then we'll finish this exercise and then continue. Okay, break time, everyone, take a break. Yeah. All right, folks, you're ready to come back in 1 minute. And we'll start at 12 sharp. All right, so let's resume in here. Okay, this is the second session for today. We're saying, okay, we want to color the top half, and the tricky part is to figure out, okay, I need the top half, which means the row number goes from 0 to height divided by 2 minus 1 inclusive. And then all I need to do is I need to extract RGB because I do need to know what is the original RGB. And now I need to make sure that I multiply threshold to RGB. But please keep in mind, the tuples for a picture can only be integers. So you should say R equals to int, you typecast R times the threshold. This would allow you to make R smaller. So like if R used to be 100, threshold is 30, dot 3, then 100 times dot 3 equals to 30, and then you typecast into integer. Because if threshold is a float, the product will be a float. But you want to keep it as integer. So typecast it into int g times threshold. B equals to int RGB times the threshold. Now I'll put this back. Image ij equals to RGB now. And the RGB variables has been updated. Okay, that's what we have. Now let's test it out. Let's use the bear. I have a bear. Yeah, we have a bear in here. We'll make the top half darker. Let's say let's load a picture. Load image bear.jpg. And then what we'll be doing is we have to call the function. I think it's called, what's the name of this function? Change. So change this picture to be a dot 5%, 50% of the brightness of before. Now let's save it. Save image. Save this picture, call it new bear.jpg. Okay. So if I now run it, Python darken.py. This is the original bear. New bear, as you can see, the top region in here is darker. But as you can imagine, we are not 100% sure if it's indeed 50% of the darkness before, right? How do I do it? You can use that image string to file. Once I load it as an image string to file, save this picture as the original.txt. Once I process it, you save it again, save it into after.txt, and then you examine the RGB values. Right now, I'm doing 50%. So let's try it. Now I will focus on the original. Just pick any of them. Like, for example, this one, 52, 56, 31. Half of them should be 26, 28, 15 in this location. So it should be 26, 28, 15. So it's exactly what we are looking for. Exactly 50%, right? So now you're pretty confident that this indeed is working to give you 50% of what the RGBs used to be. Okay. Are there any questions about this coding challenge? So in here, don't forget to typecast. If you don't typecast, you're gonna have problems. And also don't forget to use double divide. It's integer division. Okay. If the threshold is above 1, that's a good question, right? If this thing is above 1, then we have to make sure that it doesn't go above 255, right? And the way to do it is you can use the mean function to bound it to 255. That's what we have. Yeah. Any other questions? All right. So that's the first exercise in here. Now we are done with the fundamental processings. There are many other special effects that you can do. Let me give you a quick demo of other effects. For example, if you load this bear and say, okay, let's create some other special effects. We have seen like the RGBs, right? Like filter out certain colors. You can also say, like, for example, create a negative effect. I don't know how many of you have used cameras that has a film. The film is like the negative effect of a regular picture. So all you need to do is to say 255 minus the RGB values. If the new RGB is the exact complement of these RGBs by 255, you're going to see the new bear give you a pretty interesting effect. For example, this is the bear. The new bear would look like this. It's like pretty cool effect, you know? So you're looking at all of them being the opposite color. Yeah, that's one thing. Another cool effect that you can do is, I like this effect too, the average, you know. So if you say, I have a picture that looks pretty nice, but I want to make it black and white, how do I do it? It's pretty straightforward too. You get RGB, you get the average of the RGB, and then the new tuple you create is simply the average, average, average. And by doing this, your picture now would be pure black and white. Okay. So if I run it, the old bear is like this, but the new bear, I need to close it. New bear is like that. So it's pure black and white, but you can see different shades of black and white, right? So it's not a pure black and white, it's more like a gray scale picture. Yeah. So there are many special effects you can do, but it's mostly manipulation of individual pixels. Are there any questions? All right. So we're going to move on from fundamental picture processing now. We're getting into geometry. So this part can be confusing, okay, but we'll see. So when we try to process a picture using some sort of geometric effect, for example, you can mirror. That's the first effect we'll try to get to. Mirror is you have a axis of symmetry, and then you can mirror from left to right or right to left. For example, if you say this picture has a axis of symmetry, you mirror the right side to the left side, and this is what it looks like. If you say mirror from left to right, this is what it looks like. Mirroring effect can give you very interesting effects. You know, so how do I do this? How do I do something like this? The key concept in here is the coordinates of different pixels as you try to mirror from one region to the other region. You know? So for example, if you say I have this pixel in here for the picture. If you look at it, it's in here, right? Where should I mirror it to? If I want to mirror from left to right, I need to mirror it to this spot, right? That's kind of the idea. You copy from one pixel to the other location. And the way you have to think about it is you can give yourself some example, right? To say, okay, what is the right way? Let's create a simple picture. Let's say I have 8 pixels. How about that? 0, 1, 2, 3, 4, 5, 6, 7. If I say mirror against the middle, so I have exactly 4 pixels on the left side, I have exactly 4 pixels on the right side. This one should be mirrored over there. This one should be mirrored over here. Similarly, now what's the pattern? What's the pattern? The pattern you should think about 0 will go to 7, 1 would go to 6, 2 would go to 5, 3 would go to 4, right? A lot of times for beginners, you try to say, hey, what's the pattern as I go down? That's not what we are looking for. Okay. The pattern that goes down, in fact, is controlled by the loop. What we care the most is, how about I give you an eye? What should be the target result? You have to generalize from what you observed in your examples. So 0 goes to 7. What's the relationship between 0 to 7? If you look at them, they always add up equals to 7. What's 7? 7 is like the width minus 1. In other words, if I give you I plus whatever this thing equals width minus 1, so this thing would be width minus 1 minus I. Whatever I is. If I 0, it's 8 minus 1 minus 0. If I is 3, it's 8 minus 1 minus 3. So that is the pattern, and hence this code in here. Let's explain this code in here. So what does it do? You have the width, you have the height, and the mirror point is half of the width. If width is 8, then half of the width is 4. So you are going through the entire height. Width-wise, you only go up to the mirror point, not including the mirror point. In other words, my width would be from 0 to 3. That makes sense, right? Because if width is 8, mirror point is 4. So range of 4 is 0, 1, 2, 3. So it's going to be this region. This will be my source region. I will grab the RGB value from a certain spot in my source region, and then I would copy it to the target region. For the target region, if you do a horizontal mirroring, it's going to have the same row number, right? The same row number from here to there, they're on the same row. The column number is different. How do I figure out the column number? The column number is the width minus whatever the column number of the source code minus 1. So now source code, source pixel, and then minus 1. So that's it. This would allow you to mirror from left to right. Any questions? Okay, let's do a quick demo in here. Okay, so we have. Let me create another challenge. Let's just I'll make a copy of this one so it's easier. Week 3 Thursday. Where's week 3 Thursday? There we go. I just copied the darkened top. Okay, so I'll call this demos. I'll just demo the mirroring and flipping later on. So I will rename this file. I'll call this demo.py. Okay. So let's try to demo a mirroring in here. So from CSE ATA image import asterisk. We will demo. We'll load the picture. So image equals to load image, I'll say bear. I would grab its width and height. So width equals to the width of image. Height equals to the height of the image. Now, the mirroring location is the mirror. So mirror point equals to half the height divided by 2. Sorry, mirror point is half the width since we are doing the mirroring from left to right. And then the way to do it is for I in range of H, for J in range of the mirror point. So we are specifying the left half of the picture. We'll get the RGB. And then I will copy it to a different spot. Same row number, but width minus J minus 1 equals to RGB. And that's it. I'll save it. Save image. This image, new bear. .jpg. Okay. So let's run it. Python demo.py. You can see bear. Now new bear is mirrored from left to right. Looks weird. Looks like a turtle. But the idea in here is if you simply fold this picture from left to right, and that's exactly what we're getting. Any questions about this part? How the mirror works? The trick is you have to realize this geometry. All right. A few exercise about mirroring. So when I run this code, okay, what are the first 3 locations I would process? Assuming the picture has a height of 50, width of 100. What are the 3 pixels that I would copy from the left to the right? A, B, C, D, or E, none of the above. Let's look at it and vote in, please. Vote in. Okay, so which are the pixels that will handle, the first 3 pixels will handle? All right. We disagree with each other a ton on this one. So how do I know which are the 3 pixels? Well, if you look at it, the first round, I would be 0 for sure. And J would go from 0 to some other value. In other words, the first 3 pixels, since the height is pretty big, so the zeros, so the the row number must be zeros. So D is incorrect, I can tell, because the first 3 pixels, they're all gonna be copied like this. So from here to here, from here to here. So it's like you're taking care of each of the rows. So all of them have row equal to 0. So A, B, C. Now, what is the source? What is the target? J would be 0, so 0, 0 should be the first part. Now, what is the target? Target will be 0, 99, in fact. And then the next pixel is 0, 1, then the target is 0, 98. So by the 98 is 100 minus 1 minus 1. 97 is 100 minus 2 minus 1. So B is the correct answer in here. B is the logic. Any questions about this part? Why the first 3 pixels we handle like all have their row number at 0? Because this is the order that we are copying based on the loop. The outer loop is the row number in here. Outer loop, if you remember nested for loop, outer loops don't change as frequent. The counter for the outer loop doesn't change as frequent as the counter for the inner loop. Okay, that's why. Are there any questions? Okay. So when you think about solving this kind of geometry problem, right, it's slightly different from like a filter. Filter is easy, right? You specify the region, you just do some manipulation on the pixel. Geometry sometimes can be confusing. So the best way, again, you start with a small picture. And you kind of pay attention to even odd. Like you say, I have 2 pictures. As my example, this one would have 4 columns. This one would have 5 columns. And then I try to mirror. I try to do flipping. I try to do other geometry on here. Okay, this one goes here. This one goes there. So would my math work out, right? So once you give yourself some small pictures and say, okay, based on the question, I'm supposed to do this thing, you try to use the example to generalize. And in general, you are saying, I have ij. Where does this ij go to? What is the new source row number? What is the new target row number? What is the target column number? You must be able to generalize from the examples you had above. If you can figure this out, in general, you have solved the problem. Okay. So generalization is very important. One thing you have to be careful in here is make sure you think about everything is 0 indexed. And you be careful if you're not careful, you're gonna have index out of bound as you try to write your code. Your code would crash to say, hey, your index is too big. Most likely it's because your math is off by 1 or sometimes by a few. Okay. A lot of times when you are looking at geometry, it's like something divided by 2 or dimension, either the width or the height minus I minus 1 or minus j minus 1. So those are kind of the general patterns that let me try this, let me try that and see if the pattern sticks, right? So that's the idea of how you try to solve a geometry problem. Are there any questions? Okay. So this is the same code like what we saw before in the previous slide, mirroring. The question is this. if I have a picture, the width is odd, like 101 or 3, would this code work for a picture of odd width? A, B, C, D, E. What would you say? We kind of showed it works for even width pictures. How about odd? Would it work? Would this code work? Let me highlight it. Will this code work for odd with picture? Will I be in trouble? Right, that's the whole point. All right, we'll stop the vote in here. It looks like a lot of us said B will work fine, but it won't mirror correctly. Let's try it, right? So if I have a width 7, 0, 1, 2, 3, 4, 5, 6. So width is 7, right? Will this work? Width is 7, and because we're mirror, if it works on one row, it will work for all the other rows. So ignore the height in here. But the mirror point is 7 divided by 2, which is 3. So the mirror point is 3. I would go, I mean, supposedly if I only have one row, then I just be 0. And J would go from 0 to 3, not including 3. So J would in fact be 0, 1, and 2, which is these 3. And if you look at the mirror point is kind of the middle pixel, right? So J looks right so far, right? So when I look at it, when I have 0, 0, ij, it will be mirrored into 0, 3 minus 0 minus 1. No, not 3, 6, 7 minus 0 minus 1. 7 minus 0 minus 1 is 6. So from here to there. But the 7 minus 0 minus 1 is the width minus j minus 1. Width is 7. 7 minus j. So this is I, this is j. And that would work. And then j becomes 1. It will go to 7 minus 1, which is 5. And j will be 2. 2 will be 7 minus 2 minus 1, which is 4. In other words, I don't touch this middle point, this middle pixel, which makes sense, right? Because it's kind of exactly in the middle. It shouldn't be mirrored, or you can mirror at the same spot. So in fact, the code that we just looked at, it works for even width picture, for odd width picture. And you don't know that until you draw this out and you realize that's exactly what we are looking for. Are there any questions? All right, so this mirroring is a good piece of code. Okay. Now, when we try to mirror, for example, how do I mirror from top to bottom? You can also mirror from left to right or right to left. Let me do a demo of the other orders. So this is from left to right, right? How about from right to left? The right to left, you need to specify this region. So it will be, the only thing you need to change is this range in here. This range should go from the mirror point to the width of the picture, and that's it. So you should include the mirror point. Now, would this work for even width picture or odd width picture? You can check. So if you have a 7, 0, 1, 2, 3, 4, 5, 6. So mirror point would be 3, right? So I'm going from 3 to 7, not including 7. So it'll be this one, this one, this one, and this one. That's what I'll be mirroring to from the right side. So how do I mirror it? If I have, in the beginning, the ij, I'll ignore I because since we're looking at mostly the columns, initially j would be 3. Where do I mirror it to? 3 would be mirrored into 7 minus 3 minus 1, which is 3. So 3 is going to 3. In other words, I copy this pixel to itself. Is it good? It's not necessary, but it doesn't hurt, right? And then j would become 4. 7 minus 4 minus 1 will give me a 2. So 4 would be copied into 2. And similarly, you will realize 5 copied to 1, 6 copied to 0. So this code would work out just fine for odd with picture. But even with picture, you can figure out it's exactly the same. So there is no difference. So this is the right way to mirror from right to left. You're just trying to focus on the right side as the source region. The left side will now be the target region. If you run the code, this is the bear. Now I'm mirroring from right to left. The new bear would be something like this. Yeah, the bear gets a little bit fatter. But if you look at this one, I found this to be interesting. Um, it looks like the mirror part, this is like a person or dragon or something. If you mirror it in the middle, right? So it's interesting. But now the bear looks like a frog, whatever. Any questions? There's left to right, right to left. You are mostly just looking at the range, right? For top down, bottom up, you just need to focus on the height, focus on the height and its range. Okay. Let's look at one thing that is row major and column major. Okay. So if I try to mirror from top to bottom, what are the correct orders that I can mirror the pixels? Like from top to bottom, top to bottom. Which ones of them or which one of them would work? If there are more than 2 possible ways, you vote for E. Okay. Let's take a look at it. Write out the row and column number. Which one looks right? Right, so vote in, please. Which order do you think is good? All right, looks like we are still thinking. Okay, we'll stop the vote soon. Okay. All right, we'll stop the vote. A majority of us voted for D. So let's just check out D first. 0, 0 to 3, 0. 0, 0 to 3, 0. So we're doing it this way. And then 0, 1 to 3, 1. 0, 1 is here to 3, 1. 0, 2 to 3, 2. Yeah, I would say D works, right? The next popular choice is C. So what does C do? If you look at C, let's check if C is good or bad. For C, it goes 0, 0 to 3, 0. 0, 0 to 3, 0. That's good. And then 1, 0 to 2, 0. 1, 0 to 2, 0. And then 0, 1 to 3, 1. 0, 1 to 3, 1. So it looks like we're doing it column by column. Take care of the first column, then the second column. In fact, both C and D are right. The right answer in here is E. Okay. The reason is simple. As soon as you make the copy, I don't care how you copy it in what order. It doesn't make any difference. So a lot of times people say this D would be the row order, C would be the column order. So you take care of it either row by row or column by column. It looks like they should be the same, right? Because you're gonna have to copy like 12 pixels anyways from the source to the target. But in reality, there is a difference. There is a difference. In general, copy it row by row is faster. So you're gonna end up copying 12 pixels nonetheless. Then why do you say copy it row by row is faster? It comes from the fact that most of these row items are next to each other in memory. So each row, if you remember the 2D list, my status is out of battery here. Yeah, change it. Okay. So if you think about a picture, right? The interesting thing about these rows is they are close in memory. Similarly, the second row, they are kind of next to each other. The last row is next to each other. In other words, they are kind of physically close to each other. But if you go to different rows, they may not be next to each other. In other words, row 0 may be pretty far away from row 1. Row 1 is pretty far away from row 2. You never know where they are. Now, the consequence of that is if you have to jump in between these rows, often like the column order, you are wasting a lot of time on the road to go from point A to point B. A good analogy is like if you are the mailman, there are two neighborhoods you have to deliver mails to. The first neighborhood have 6 houses. The second neighborhood also have 6 houses. Whatever. And then you say, how do I deliver it? Deliver the mails. In the end, you're gonna deliver 12 houses nonetheless. But I would say any probably mail person would say, I'll take care of everything here because that next to each other, it's easier for me to deliver all these mails in here and then drive here and then deliver the other 6 mails. Instead of saying I'll deliver this person's mail and then I drive here and deliver this person's mail, then drive back, then drive backwards. So going back and forth, that's not good, right? So in general, if you try to take care of a region, you want to go through it row by row instead of column by column. Okay. Any questions about this? The difference between row major and column major? So if you take care of things row by row, it's called a row major. Similarly for column major. Okay. Let's look at this one. If I want to copy the things specified by this order, row major, what should I put in here, here, and the other blanks? We have 6 blanks. Can you fill them in? I'll give you 2 minutes. Okay. Can you figure out what you should put inside each blank? And then give me a vote once you figure it out. Okay. So think about what would you put into um, each blank. We want to follow the row major. Row major. One of us has figured it out. Okay. Last 30 seconds. Two of us figure it out. All right, let's work on this together, and then we're gonna take a small break. Okay, so I want to do row major. Row major means I need to kind of take care of the first row and then the second row. In other words, if you look at the first row, all of them have the same row number. So the row number doesn't change often, but the column numbers will change fairly often, right? From 0 to 1 to 2 and go on. So if we think about this in the context of nested for loop, I should be the row number. The outer loop should be on rows, so I should say midpoint. So the top region. J should be the columns because it's the inner loop. So J would be on the width. It's not always the case that I must be for row, J must be column. Okay. And then I grab the corresponding position, right, from the top, and then I copy it to the bottom. The way that I take care of the bottom region is they would have the same column number, right? They would have the same column number, but the row number, very similar like before, it should be the height minus I minus 1. That should be the row number difference. Okay. Any questions about this? So this one would work just like before, a quick demo. So I would say the midpoint now is h divided by 2. For I would go through to the midpoint. J is now the whole thing. If I make the flipping, the mirroring from top to down, then it should be the height minus I minus 1. So if they have the same column number, the row number changed in this way. If you run it, okay, forgot 1. There we go. And if you close the new bear, this is the original bear. Now it's flipping down. It's flipping down. This is what the new bear looks like. Pretty interesting, right? It's symmetric in here. Now, what if I will flip up, right? Mirror it up. You just need to change this range from middle point to height. Now you're focusing on the bottom half as the source, and you flip it up to the top. No other places needs to be changed. This is what it looks like when you mirror up. Looks very strange. But it looks like this is a person sideways. Nonetheless, any questions of mirroring to the left or to the right, top down? So to summarize, before we take a small break, for mirroring, we talk about row major, column major. We talk about the general rule to say it's like the dimension minus I or j minus 1 being the target, right? The midpoint, and it works for both, even with picture or even height picture or odd with pictures, odd height pictures. So the width and height being even odd should not affect how this code work. It should work all the time. Any questions about mirroring? We're done with mirroring here. All right. The next thing we'll look at is flipping, but let's take a small break. Okay. So we'll come back 1 o'clock. We'll finish flipping, most likely. We can probably finish everything here, and then we'll call it a day today. Okay. So even odd, not always, we never, so before we take a break, just one thing. Even odd never affects mirroring based on this code. Even odd wouldn't affect it. But if you have different code, maybe the even odd properties of the width or height will affect your code. But based on this code, it doesn't. Okay. And it shouldn't, technically, shouldn't affect how mirror effects will be created. Any other questions? All right, let's take a break. Okay, come back 1 o'clock. All right, folks, get ready to come back. Okay. We will work on the last segment here. Start in 2 minutes, in 1 minute. All right. Um, let's look at the last segment for today. Okay, we have a few slides to go through. First thing is flipping. Okay, flipping is different from mirroring in the sense where if you look at this is the original picture, you say I have a vertical axis and I want to mirror from left to right. When you mirror, you are copying from one region to the other. That's mirroring. Okay. Flipping is like you are, so this is copy. For flipping, it's like you swap the left with the right. So if you swap these two, you end up with this picture. If you swap these two, you end up with that relation. So for flipping, you are actually swapping the cells at corresponding locations. But that's about it, you know. So it doesn't really make too huge of a difference between flipping and mirroring. It's just because when you swap, you really cannot simply overwrite what you have in there, right? If you think about you say you have two variables A and B, you want to swap it. The way you can do it, in fact, you can use the tuple way, or you can use an approach like this. So you say, I want to flip this picture based on this vertical axis. The way to do it is your mirror point, just like before. But instead, simply saying, I grab this RGB and assign to the target, I need to grab the RGB out from the source, from the left side, RGB from the right side, and then I need to basically do a swap. I want this image IJ to point to RR, GR, BR. Similarly, the corresponding location point to RL, GL, BL. The question is, what should I do? A, B, or A and B, or B and A, or more than one of the options are good. So we're swapping two things. Can we have a quick vote on this one? Let me so vote in whenever you're ready. I need to swap 2 pixels. What would you say the answer is for this one? OT, whenever you're ready. Okay, we'll stop the vote in here. Okay. A majority of votes voted for C. I would do this assignment and then the other assignment. Well, I would say C is definitely right. Okay, C is right. I need to do both. I can't only do one of them. In fact, D is also right. The order that you do the assignment really doesn't matter because you have made the copies of the tuple and you just need to let them point to different things. I would say E is also good. Okay. So this is the idea of flipping. You are swapping two pixels. Okay. Any questions? Let me give you a quick demo of the flipping effect. Um, so it's very similar like before. Let's do the left to right. Sorry. Well, for flipping, really doesn't matter left, right, or right to left. Let's do the flipping against the vertical axis. So let's say width. In here is MP. So we'll copy it out. RL, GL, BL, and then the other location, which is W minus J minus 1, and the same I. I will grab this out. RR, GR, BR. Okay. And then simply swap them. So I just say image IJ equals to RR, GR, BR. And then the other side, W minus J minus 1 equals to RL, GL, BL. And for the bear, it looks okay, but I want to use the swan. So initially, the swan is looking to the right, right? It's on the right side. Once we flip it, the swan should be looking towards the left. So let's use the swan. Okay, and say new swan. If you run the code, you see this is the original swan, and for the new swan, it's looking to the left. So we just flipped these two pictures. Okay, so this one flipped, you get that. Any questions about flipping? Very similar to mirroring. Okay. Okay. Now, so we're done with kind of geometrical geometry on pictures. Now I want to spend the rest of the time looking at some of the potential problems you may encounter when you're writing code to process pictures. Number one thing is sometimes if you're not careful, you may be off a little bit. Like when you look at the piece of code, you have to make sure that it works fine, whether it's even width, odd width, or it's always going to work under the uh, given situation, right? So first thing, can you look at this piece of code and figure out what it does? It's kind of some sort of geometry, right? What does this code do? Take a look at it and figure out. what does this code do? If you think about it, right? It can be confusing, right? When you look at the code. And the key in here to answer the question is give yourself an example. Trace through the code. Unfortunately, Python tutor won't help you to trace code on pictures because it's quite specialized. But you can give yourself a picture, just draw it out, a small picture, and see what each of them does. All right. Um, let's look at this one. Okay. So how do I analyze this? Give yourself a picture. Let's say it looks like it's trying to take care of the width. So let's focus on the width in here. Right, the height is like the entire height. So let's draw a picture of 7 columns. By 7 is a bad number, right? It's a prime, it's odd. So if anything may break the code, maybe this is a good choice. And also you can draw a picture of size 8 just to make sure that it works on even and odd. So if the width is 7, I will ignore the height because it looks like none of them has anything to do with the height. Image width divided by 2 will be 3. So magic will be 3. For heavy roll, my countdown equals width minus 1, so countdown is 6. For J in the range of magic, magic is 3, so J would be 0, 1, 2. I grab a corresponding pixel. When J is 0, I'm looking at this one. And then say image countdown equals RGB. So I'm copying this thing to this location. Same I means it's the same row. Counting down right now is 6. So 0 copy to 6. And now counting down decrease by 1. Counting down is 5. And then this loop would run 3 times. The next round, J is 1. Counting down is 5. And then a decrease countdown again. Countdown will be 4. 2 to 4. And that's it. So this one would allow me to mirror from left to right, at least on an odd width picture. How about even width? Right, so let's say 4. 0, 1, 2, 3. You erase these things in here. So if the width is 4, magic is 2. Counting down will be 3 in here, okay? So for J in the range of magic, in the range of 2, J would be 0 and 1. Right, so J would be 0 and 1. Initially, I'm looking at 0. 0 will be copied into, sorry, it looks like whenever I use PDF to annotate, my screen turned into a, try to make it darker. Sometimes that would help. Okay. Sorry, it looks like my screen is getting fuzzy in here. Hold on. I think this is one of the problems with, let me see. Okay. So let me do a quick change. Okay. Sorry. Okay. So the screen is unshared. Hold on. Do extend again. All right. Looks like now it's getting back. sorry. There we go. Yeah, for some reason, when I annotate on PDF, sometimes it just maybe it's getting overheated or what. Sorry. For the distraction, um, let me go back. We're looking at even width picture, even width. So half of the width is 2, counting down is 3. We're going from j equals to 0, right? So if j is 0, we're looking at counting down is 3. So 0 copy to 3. And then counting down becomes 2. And then j is now 1. 1 will be copied to 2. And then I'm done. So this one is going to copy the left half to the right half, mirrored. Or mirrors around the vertical axis from left to right. So C is the correct answer in here. It is mirrored. It is mirrored. Okay. Any questions? So number one, when the code is not like in the standard form that you see, you have to give yourself examples to figure out whether this is good or bad. Okay. Use even odd width and or height and try to see what it does. Okay. You do not want to create too many like the pictures should be like maybe less than 5 by 5. So the 7 is, I mean, 7 is okay, but no more than 10, I would say, on each dimension. So you can see the pattern. Okay. Questions about this exercise? Last part. This is a much common problem that we see. Okay. For next week's assignment, you're gonna do a flipping of a certain region in the picture. So one of the common mistakes that we see as students do those kind of exercise is you're off by 1. For example, your region is supposed to be 20 by 20, but you carve out a region of 20 by 19 or 20 by 21. So you're just off by 1. You got to be very careful in here. Okay. So let's look at some of the examples and we will kind of practice how to avoid off by 1 error. In here, I want to create a red box, not black box, because this color is red. Now, what is the exact dimension of this box? Exact dimension. Okay. Vote in whenever you're ready in here. What is the dimension? What is the exact dimension? Okay. All right. So let's take a look at it. We disagree with each other a lot. Look at this. So how do I do it? Right. First thing, how do I determine the width? Width is related to the columns. Height is related to the rows. Columns are on the second dimension. Rows are on the first dimension. So this one the range for I would determine the height. What's the range for I? 1 to 5. If you look at it, if you go from 1 to 5, the exact height will be 4, which is exactly 5 minus 1. Okay, that's it. So you can also count 1, 2, 3, 4. That's it. So now how about the width? Width is exactly 50 minus 40. But this will give me a 10. So it should be a 4 by 10. Width should be 10. Height should be 4. None of them is right. That's it. So if you are looking for, okay, what's the width of my range? Just the bigger number minus the smaller number. That's it. That's the exact number of data you have in that range. Any questions? So this one is none. None. And don't confuse row with column. So rows are related to height, columns are related to width. Last exercise for today. I want to create a black box of width W, height H. I don't care where this box is. These codes, they're gonna create potentially a box that is colored black. Which one of them would give me an exact W by H? W is the width, H is the height. A, B, C, D, or more than one of them. Let's vote in. Okay. I'm looking at exactly W by H. Okay, not one more, not one less. Exactly. Width should be W. Height should be H. Two of us have voted in. All right, we'll stop the vote. The most popular choice is C. I agree, right? So width is column. So this is exactly H by W. So how is the H by W? Remember, if you don't have this starting point, it is 0 to H, which is H minus 0 is H, 0 to W, W minus 0 equals to W. So this one is good. I would say C is good. One of us voted for A. Let's check for A. But this one is not. The reason is if you go from 0 to H plus 1, right? And if this is in the range, the number of things in between 0 and H in this range will be h plus 1, in fact. Remember, if you have a range of a to b, the number of things within this range is exactly b minus a. That's what we have. So a, unfortunately, isn't. Okay. How about b? Row in the range of 10 to h plus 10. Now, how many things are in between this? Is exactly h plus 10, the ending point minus the beginning point, which is exactly h. Similarly, this is w. So b is also good. So it looks like E will be the right answer. But also let's look at D. How about D? This is a negative step size, which is a little bit strange. But you're gonna start from H, right? You're gonna get smaller, smaller, all the way to 1, not including 0, here. Okay. So if you count how many things are between 1 and h inclusive, is again exactly h. Similarly, is exactly w. So D is also correct. So B, C, D, they are all good. B, C, D, they're all good. So the answer would be E. Okay. Any questions? So when you are creating a box, make sure you are not off by 1. Okay. If you are not sure, oh, what if I make a mistake? How do I even know I make a mistake? You give yourself an example, like if W is 4, H is 7, I say range of H plus 1, range 8. Would this give me 7 numbers? You can quickly realize I made a mistake, right? So give yourself some concrete numbers and see if your formula would give you the right thing. I think that's the best way to avoid potential off by 1 errors. Any questions? Okay. So to summarize what we learned today, we talked about the basic image processing, mirroring, flipping, and also we stress on off by 1 error. So avoid that. Okay. Just a quick reminder that we have a quiz tomorrow. Make sure you work on the quiz. Okay. Other than that, we are done today. Are there any questions?